Hey, hey. Please welcome Stef with his talk about hacking a hardware fiber router.
Thank you. So, hi everybody. A few days before the call for papers deadline was starting, I basically decided, like, well, I should also try to give a talk and contribute something. So I ended up with a rather quick submission about hacking some hardware. Basically, my goal here is right now to talk a little bit about the process of going through a hardware pen test to keep it as a sort of learning thing as well. So who am I? My name is Stef. I work at KPN in the Netherlands. I'm part of Tech Inc., which is a hackerspace in Amsterdam. I help organize Hack in the Box. I help out with privacy cafes in the Netherlands and some other stuff. So towards this talk, with hardware is a really fun thing. If you hang out with a hackerspace and such, a lot of the same skills apply there. There's a few points I want to make. First of all, it's also still a place where you can find a lot of bugs without going through like months of hardcore research, which makes it kind of fun. So we did a pen test on something called a GPON router. That's basically a fiber optic router which has been made around, or a standard which has been made 10 years ago. But it has some pretty good specs and it's still being used at quite a lot of countries in Europe. So to start looking at a router, we basically wanted to look whether a customer having a router in his house would be able to hack the router and possibly attack our network or create some denial of service issues, stuff like that. We have a nice Raspberry Pi setup with two USB to fiber converters, which we were planning to use for this pen test. Turns out they completely didn't work due to different specs and standards. So then we basically said, like, okay, the best way to look at what's actually going on is to get a shell on the router and look at the network from that perspective. And the thing is, if you place a hardware device in somebody's house, they have physical access. So getting a root on a device like that is mostly a matter of time. There are hardware defenses which you can do, secure elements, stuff like that, and then it becomes a lot more harder. But for a consumer router which is mass produced, these kind of investments are normally not made. So the general approach when looking at devices like this is there's a few interaction points that you have. Obviously, on the network side, it will have some Ethernet adapter and fiber uplink in this case. Another approach for attack is basically to look at the physical aspects of the device and see what you can do with that. And in some cases, you might look at the wireless stuff as well, but it tends to not be the first thing you try. So we were asked to do this pen test. We told the project, like, please send us 3 of these devices, because from experience, we know 1 or 2 might get bricked during the pen testing process. And then there's some quite logical steps that you start out with. A lot of these devices have debug interfaces. These are used for fixing a broken device when it gets sent back to the manufacturer, stuff like that. So you tend to go around hunting for debug ports. When you find some, you try to establish where there's a ground, because that's something you're going to need to have working communication. So you play around a bit with an oscilloscope to figure out what the ground is on the pins, and then you hook up a logic analyzer to basically see what kind of protocol is being spoken. I'm a big fan of the Soleil logic analyzers, especially because their software is really, really good and extendable. But these are not cheap. I use these at work, but there are some alternatives which you can find on Alibaba, which are compatible with the same awesome software. And especially if you like travel around to a camp or if you're a poor student, I would recommend that. If you work for a company, I would recommend actually buying a SLA because they did basically write some really good software and supporting them is useful. So, as mentioned, you find the ground, you analyze some logic. There's a couple of different kind of devices to talk various protocols, typical serial to USB cables, and some other stuff. And as I mentioned, I'm not going to focus on the network part. The device basically had telnet and a web server open, which didn't seem that interesting, but we'll get back to that later. So these were some of the pins we found, and quite quickly we were like, okay, we hooked up some serial, and you see a device booting. So at that point, it's basically like, okay, this is working serial, it looks pretty easy. We can probably type admin and 1234 or something like that, or interrupt the boot, and well, this should be easy. We'll get some roots and stuff, and then we'll have a nice lunch. Then, after the whole demessage thing happens, we were dropped into a rather weird command line interface. As you can hopefully see, we did find out that if you type enable, the shell sort of changes. And we ran some commands that we found through running strings on the binary to see what would happen. But basically nothing was really clicking there. So, because this wasn't going as great as we were hoping, we decided to look a bit more at the physical aspects. So basically, these routers have flash chips, which store the file system, which is used to get into a running state. And depending on the kind of chip, you can probably just solder some cables on and talk SPI. If the chips become really complex, like ball grid chips with little balls on the bottom, or very tiny feet on the sides, you kind of want to use something called a device programmer, which is stuff you can buy these days from Amazon for a couple of €100. You see the small cradles on the left bottom of the picture, which are basically different cradles for different kind of chips, which makes it very nice because you can support a lot of different flash chips with that. This tends to also involve using a microscope to figure out exact chip number. So you can actually tell the device programming software, which is a lovely piece of crappy software from China, what is actually supposed to do with it. So let me make one thing clear. I have always been much more a software guy. And as you can see on this picture, soldering is definitely not the thing I'm the greatest at. This was the first board we used. It did sort of work, but after a day it stopped working, probably because we short-circuited something or something just moved a little bit. So later on we built a rather nicer setup, which one of my colleagues soldered, and then it actually stayed working. But still, it worked. We had some cables hooked up to the flash chip, and we extracted the firmware from the device. And one of the nicer tools for analyzing firmwares is a program called binwalk. If you play around with binwalk, they have a whole wiki how to set it up with all the various extra plugins and programs. So it's very advisable to actually go through the entire walkthrough, install all the weird kind of tools to talk different file system formats, because if you just run it from a clean installed Kali machine or something, you will get a lot less output. But anyway, we have a firmware, we can extract the file system, so that gives us a lot of stuff to look at. And because we want to get a shell on the device, one of the first things which came to mind is basically just replacing the binary on the file system with a shell and hoping that after flashing the firmware back to the chip and putting the chip back on the device, you would expect to get a shell. That didn't work. Basically, After making these modifications, you got a CSC error from the firmware, which basically said like, well, you know, you modified stuff, the CSC is wrong, so I'm not going to boot it. Next, well, during that, we found out that we had been flashing our firmware into the recovery image for a long while, and that basically meant that it didn't work at all at first. After we flashed both of the partitions with our new firmware image, we got these CSC errors. Because the security here is not that great, the CSC is just something that's stored in the firmware itself, so you modify that, you figure it would then still boot, but it still didn't. Now, most of these devices tend to have like a small embedded Linux version, tends to use BusyBox for a lot of different things. So the binaries is a symlink to BusyBox, which might mess up some things based on if all the partitions are mounted yet, stuff like that. So we're like, okay, we'll just make some other binary, replace the CLI with that, and go from there. So with MSF Venom, I made a little MIPS reverse shell program. We copied that over, and that didn't work either. And basically, as we went through this pen test, we found out that this device was running a rather old and not often supported version of MIPS, which basically meant that a lot of the tools that you would normally use would not work on this box. As you do a pen test on a physical device, there's some other text that you would often use, which is basically try to interrupt the boot process and modify the boot args of the kernel. Putting a space 0 behind a typical boot argument tends to instruct the device to boot into single user mode. But again, that didn't work either. We tried some other things like changing the init to binaries, etc. Yada, yada, yada. Short story, it all didn't work. Because we had been reflashing this chip for a while now and it was becoming a rather tedious process, we basically decided to use the cradles that we used for the device programmer to make it much easier for ourselves to take the chip out, reflash it, and keep going. And I'm rather glad we did. So this is the picture of that. We basically took the wires from where the flash chip is stored or located. We hooked up to the little cradle thing at the bottom, and that gave us a setup to keep reflashing, keep trying new things. But as I said, a lot of the modifications didn't really help, so we had to think of some other approach. One of the things you can do when you're interacting with hardware is something called glitching. This can be very fancy stuff where you drop the power a little bit to mess with loading things, to mess with encryption of a device. There's people doing crazy stuff with lasers, but what we did was basically just pull the cable between the flash chip and the board while it was loading, which generates a loading error, and then these kind of devices tend to drop you in some kind of prompt for you to figure out why the hell the board isn't booting anymore. At the bottom of this output, you see some of the commands you could do from like, this is basically from grub or the equivalent of that on a hardware device. We also noticed that if we interrupted the loading later on in the boot process, you would actually drop into a shell. You were already root on the device. But the issue is you don't have a running device then. So the network stack hasn't been loaded, the fiber isn't working, and I can claim, well, yay, we have root, but it's not very useful, as the next slide basically says. When we do pen testing at our work, we work with teams of 2. That really helps because it means that you miss less things, it means that you can bounce IDs off each other. It also means that you can take multiple approaches at the same time and see what gives you the results in the most quick way. because most of these assignments, at least when you're doing it for a company, tend to be time-boxed. So you have 1 or 2 weeks to break the device, and if you don't manage in that time, you can basically say like, well, if I had more time, I would have managed, but that doesn't really look that cool. So me and my colleague decided, like, basically, I was playing with the whole interrupting the boot process, trying to get that working, and he was looking at the binary itself, which was the GPON CLI that you were dropped into. Now, there's a couple of tools which help a lot when you're trying to reverse ARM binaries. There's IDA, which is really nice, but very expensive. There's now also GHydra, which the NSA released. You can put some question marks around why they did this, and whether there are issues with that kind of software. I mean, I do run it in a VM that's not network connected, but it is really nice. And this is GHydra basically taking ARM assembly and reversing that into mostly readable code. And they actually support a serious amount of architectures, and they have some really nice features where you have the assembly on the left side, the code on the right side, and if you click somewhere in the assembly, the code on the right side also gets updated basically where you are in the program. So looking through some of the binaries, you start seeing some code with string compares to root, and then the second string compare to admin, and a similar thing with admin and 1, 2, 3, 4. Some other stuff you notice is like some comparisons to base64 encoded strings in there, and some other code that's basically checking a password character by character. Also, while analyzing this command line binary, we found some code paths which showed that if you typed enable and then pressed an L, you would actually get into a function which was doing something with usernames and passwords. I tried a lot of different commands, but I didn't think about pressing L on a binary to get a login screen or a login string. But as we found out, it's not like a default username and password combination. It's actually based on the serial of the device, which means that you cannot reuse the same username and password everywhere and consider all the routers pwned. But we did notice, like, okay, the serial is on the box, which is nice, but that does make network-based attacks harder. Like if I'm trying to hack your router somewhere, but I cannot physically look at it, that helps a little bit. This is like, you know, putting the Wi-Fi password on a sticker and not somewhere else. But the device was also running telnet, and with the default credentials that we found, we could log in on the telnet, and it would give you the serial number. So basically, they made some kind of algorithm which takes a username, and then there's a password based on this serial. And then you can try to reverse engineer the entire thing that they made to get the correct password for a given device. But what you can also do is run the binary yourself and just start interacting with it. It took a little bit of time to get this set up with QEMU, but this link has a nice write-up about how to set up a system like that. And with that, we basically could create some file which contained the serial number, because we could see with strace or stuff like that that was being loaded. We put some breakpoints in the binary on the string compares, and then quite quickly, you can basically just type in a username, a wrong password, you hit your breakpoint, and you see the string compare being done. So that gives you the password that you can actually use to log in on the command line interface binary. And then there's some menu options, including something called system with a shell submenu, and then you have a root shell on a working box. So that's nice. We're making some progress here. We have a root shell, but the goal for us was mostly to see if there were any risks on our network from the perspective of the router. Because the router has firewalls and stuff, so a person behind it might not be able to do as much things as a person being root on the router. But as I said, it's a small device. It has like 8 MB of flash, so there's not a lot of stuff installed. There is BusyBox, which is useful, but no options to dump the traffic, no easy tools to scan, and it's running a really weird architecture. Buildroot is a really nice framework which basically allows you to use a sort of make menu config thing to select, like, I want to compile for this architecture with this version of Linux, with this version of libc. I've used that before with great success, but because of this weird MIPS version 1 thing, that didn't help. So with the working QEMU system that we did build, we decided, like, okay, we'll try to compile some binaries in a static manner in the QEMU system, get them onto the device, and use that to start exploring the network traffic. Then turns out that they were using this weird version of libc, which meant that we basically had to end up building another VM to get the compilation working, but ulibc has some really nice downloads for you, where you basically just download this whole tar file, you run a setup.sh, and you end up with like a whole system to compile in. Some other stuff we tried, because that tends to help as well, is basically just look for somebody's GitHub project where somebody already did the static compilation work. And the issue is you don't really need static binaries, but they make things a lot easier. So you do kind of want those. We also looked at like different write-ups from other people who hacked routers to see if they possibly extracted binaries that worked on the same CPU architecture that we were using, but it all didn't really help. The thing is that if you don't have Nmap, you're probably still going to be fine, and you can still do port scans into the network to figure stuff out with some bash for looping or some other small tricks. And I think we spent 3 days on getting a working TCP dump. In the end, we got one. We looked at the network traffic, and it was pretty much just what you would expect. No credentials going over there. No one expected SNMP. So they designed that pretty well. From the network side of things, we basically just found one small issue. There was a DSLAM, the DSLAM is the first hop from your router at home into the telco network, and that had some telnet enabled, which it shouldn't have. So we informed the vendor about that. They will change that, but for now we just firewalled that off, and that issue is resolved. So at the start of this talk, I mentioned a little bit about the telnet, which was available in the web server. So while we had root on the device already, a colleague of mine, who wasn't even doing the pen test, but who was looking with us because we found it interesting, found some write-up online from something called VPN Mentor, and I think that's a company who also looks at like the security of their own devices that they implement. And they wrote this really nice blog about a lot of the vulnerabilities which they found on a GPON router, which looks rather similar based on the kind of output they had online. And it also showed that, we did take a quick look at the web server, and we're like, well, I don't see a lot of stuff going on there. It's mostly a few static pages, some functionality, but not a lot going on. But it turned out that there were whole like subdirectories and other parts which were findable if you went through that web server binary with your hydra or equivalents. So this is a really nice article from some other people who did similar research. The article mentions that these vulnerabilities were fixed. But we did decide to take another look at the web server because we had some time left. And then you run into a web server which is not designed very well. For some reason, and we didn't figure out why, just requesting the /style directory on the web server crashed the web server and rebooted the entire router. This is software written 10 years ago. It's normal to see this kind of stuff on a lot of hardware devices, but yeah, it doesn't really fill you with confidence either. Another issue that the VPN mentor guys found is that you could bypass all authentication by appending some short string to the URLs. This was supposedly fixed, but on our device this still worked. It could have been like a different software branch or a slightly different version of the device. We were running the latest firmware, but the issue is still there. And because there was an authenticated feature to disable the firewall, we could use this out bypass also to disable the firewall, enable the telnet, and do some other stuff. If the telnet would have actually been disabled on the device, this would have been a nice find, but the whole telnet thing was open anyway. We did tell them, we want you to disable the telnet, and then this issue starts to become a bit more relevant, so you also need to fix this. To continue a little bit about that web server, the guys from VPN Mentor also found command injection in the web server. And that was fixed on the parameter where they reported it, but not on any other parameter. So I think this is my colleague who quickly looked into this. And then we found out that we could have popped a root shell from the web server if we had spent a bit more time looking at that initially. But we were excited to play with hardware, so we found this out a little bit later. And to continue about that web server, this is what happens if you do a little curl command towards the web server with a kilobyte of A's. It wasn't exactly a kilobyte. I kind of summarized this shorter. I think it was 1037 characters to hit the exact overflow point. But as you can see, the ABCD at the end is basically returning in the address of the segmentation fault, which is a very strong indication that you control the flow of the assembly. So with a bit of time, this turns into a working exploit. Basically, this was for us the end of the pen test. We had root on the device, we had a whole bunch of issues to report to the vendor. We looked at our network and we figured out that at least that looked pretty clean from the consumer perspective. We spoke a little bit with the developers who basically said yeah, a lot of this stuff is local. It is exploitable, but you need to be on the same LAN. That is true. This is not the kind of vulnerability which easily turns into a large botnet. But there are some people who did some interesting research on certain attacks. DNS rebinding is one of them. You can Google that and read a lot about it, but basically it on the fly changes the IP addresses that certain DNS records point to and trick the browser into making a GET request into your internal network. Stuff like that. But on the positive side, we won't name the vendor because that's kind of like making fun of crap that everybody has. I haven't seen one serious network equipment vendor which didn't have these kind of bugs in their equipment. And then I'm talking about all the big ones which exist. But they were really nice in terms of when we handed over the report to them, they immediately responded. We exchanged some PGP keys. They got working on resolving the issues. And in 2 or 3 weeks, they reported that they resolved 8 out of 10 of the issues. They There's two things that they needed a little bit more time on, which was the fact that everything was running as root on the device, and that it was using a Linux kernel from 10 years ago. But with these initial things fixed, and this is, of course, nice. The initial hardening around the crappy old software was there. So to us, that was good enough to say, like, you know, when we have the new firmware, we can at least start deploying this. So the conclusion is basically that this is fun to do. There's, if you're looking to get more into IT security, possibly work in that field, hacking some of the hardware that you have at your own house is a fun way to get into things. And as I said, probably easier than trying to do really advanced research, and like a lot of stuff like Apache or NGINX, it has been tested a lot, and that makes it harder to find things. And this is not the case with IoT hardware. So basically, this concludes my talk. And if anybody has a question, I'd be happy to answer those.
Thanks. Any questions? Obviously no. Then thanks again for the talk.
Thank you.